अस्सलाम वालेकुम स्टूडेंट्स। ये जो बेसिकली मैं रिकॉर्डिंग कर रहा हूँ, इस रिकॉर्डिंग में एक्चुअली आई एम गोइंग टू डिस्कस अ वर्कशीट which comprises on the questions from general physics. Okay, general physics includes kinematics, forces, deformation, momentum, movement, work, power, energy, pressure. Okay, so this worksheet comprise on the questions from these 6 to 7 topics. Now, so I'm going to solve this question, and apart from solving, I'm going to tell you the strategies or the concepts. Okay, students? Now, the very first question. In the first question, figure 1.1 shows a water skier pulled horizontally across a water surface. The mass of the water skier is 60 kg. Okay, the mass of the water skier is given to you, and the gravitational field strength is 10 newtons per kg. But from now and onwards, the value of G is 9.8 newtons per kg. But 10 newton per kg is given to you in the question, so we have to use this value. Now, calculate the weight of the water skier. So, bachcho, the formula for the calculation of weight is mass times gravitational field strength. The mass of the water skier is 60 and the gravitational field strength is 10. So the weight is 600 newtons. Now, in the next part, mass and weight have different units. State two other differences between mass and weight. So the major difference between mass and weight is the dependence on gravitational field strength. Okay. Mass does not depends on gravitational field strength. Mass does not depends on gravitational field strength, students, but weight depends upon gravitational field strength. Okay. But weight depends on gravitational field strength. It means, bacho, when you are going to take a body on the surface of a moon, if the mass of the body is 60 kg on Earth, then the mass of the body also remains 60 kg on the surface of the moon. But on moon, the gravitational field strength is 6 times less than the value of G on Earth. So at the surface of the moon, the weight of the body decreases, but mass remains constant because mass does not depends on gravitational field strength, but weight depends on gravitational field strength. Now, in part C, a boat pulls the water skier to the right with a horizontal force of 50 Newton. So guys, horizontal force of 50 Newton is given to you. And the main important point is the water skier travels at a constant speed. So this is an indication that all the forces which acting on the water skier are equal to each other or balanced in nature. So the resultant force will be zero, because resultant force will be zero in two conditions: when the body is at rest or when the body is moving with constant speed. Because in these two conditions, all the forces acting on the body balances each other, okay, and the resultant force becomes zero. So explain in terms of the horizontal force acting why the speed is constant. So you should write down all forces are balanced in nature, and you will get 1 mark when you write down all forces are balanced in nature. But if you write down and resultant force is zero, then you will get the other 1 mark. Now, the horizontal force acting to the right increases from 50 to 70. The horizontal force increases from 50 to 70. The size of any other forces are unchanged. Calculate the acceleration of the skydiver, water skier. Okay, calculate the acceleration of the water skier. Now, students, the horizontal force acting to the right increases from 50 to 70. The size of any other forces are unchanged. Okay. Now, you have to calculate the acceleration. So, students, you all know that the water skier travels at a constant speed. So, when the water skier travels at a constant speed, so all the forces acting on the water skier are balanced in nature. But the horizontal force acting to the right increases from 50 to 70. So now first you have to calculate the resultant force, okay? Because you have to use the equation F is equal to ma. Okay, bachon, so you have to calculate the resultant force, then you are going to calculate the acceleration. So bache, the sizes of any other forces are unchanged. Only the horizontal force acting to the right increases from 50 to 70. So there is a difference of 20 Newton in the horizontal force. Okay. So the value of F will be 20 Newtons. The value of mass is 60 times A. So A is equal to 20 divided by 60. So guys, the acceleration is 1 over 3, or you can say that 0.33 times. 0.33 meter per second square. Now, so in second question, figure 3.1 shows a syringe mounted vertically in a block of wood and sealed at one end. A plunger is free to move inside the syringe. So guys, you have to see the diagram carefully. There is a plunger and this is a syringe. The plunger is moved down the syringe and there is an air trapped inside the syringe. Okay. And the other end of the syringe is sealed. Now, the air inside the syringe exert a pressure on the wall of the syringe. Define the term pressure. So students, you all know the formula for pressure, which is force divided by area. So you have to write down force acting on unit area is called pressure. Unit area means 1 meter square area. So if the area of the surface of a body is 1 meter square and the force acting on 1 meter square area, so that force is actually exerting or developing pressure on the surface of an object. Now, explain how the air molecules in the cylinder of the syringe creates a pressure. So guys, when the air is trapped inside the syringe, so the air particles are in constant random motion. So due to their constant random motion, they make frequent collision with the wall of the syringe. So when they make a frequent collision with the wall of the syringe, so during the collision, they apply force on the wall of the syringe, and the wall of the syringe has certain area. So when the force acting on an area, so it ultimately develops. So this ultimately develops pressure inside the syringe. So you should write down air molecules. You should write down air molecules moves randomly and make frequent collision with wall of syringe. Okay. And during collision, air molecules exerts force on wall of syringe causes causing pressure. Now guys, in part C, a weight 10 Newton weight is placed on the top of the plunger. Okay. 10 Newton weight is placed on the top of the plunger. The plunger moves down slowly so that the temperature of the air inside the syringe does not change. It means temperature is constant. So students, when the temperature is constant, so pressure is inversely proportional to the volume according to pressure volume relation, which is known as Boyle's law. Okay. Now, before the weight is placed on the top of the plunger, the pressure inside the syringe is 1 exponential 5 Pascal. So this is P1. Okay. And the volume of the air is 50 cm cube. This is V1. Now, the cross-sectional area of the plunger is 1.2 exponential. So students, in part 1, calculate the pressure of the air in the syringe after the plunger stops moving. So you have to calculate the pressure in the syringe after the plunger stops moving. So, बच्चों, the force of 10 Newton is applied on the plunger. Okay, 10 Newton is applied on the plunger, and the cross-sectional area is given to you, which is 1.2 exponential minus 4. So, guys, what we have to do? We have to use the equation pressure is equal to force over area. Force is 10 and the area is 1.2 exponential minus 4. So the answer is 10 divided by 1.2 exponential minus 4. The answer is 83,333.33 Pascal. Now, the pressure in the syringe after the plunger stops moving can be calculated by adding atmospheric pressure, which is the pressure of air inside the syringe, 1 exponential 5. Okay. So you have to add up this pressure 0.33 plus 1.0 exponential 5. So the answer will be 1.83 exponential 5 Pascal. So this is the pressure of air in the syringe after the plunger stops moving. Now, guys, calculate the volume of the air inside the syringe after the plunger stops moving. So you have to calculate V2. So for calculating V2, we have to use the equation P1 V1 is equal to P2 V2, and we have to make V2 subject. So P1 V1 over P2. The value for P1 is 1.0 exponential 5, which I mentioned in the above, So the volume is 50 bache, and the pressure is 1.83 exponential 5. Now, the final answer is 1.0 exponential 5 times 50 divided by 1.83 exponential 5. The answer is 27.3. So 27.3 cm3. So guys, you have to round up the value, and it will become 27 cm3. One shows
or
the speed time
60.
graph for a car traveling on a straight horizontal road. Okay, so this is a graph, and or this is a graph of a car, speed time graph of a car traveling on a straight horizontal road. So first you have to understand the graph, Pacho. So this portion AB of graph shows that the car accelerates uniformly. Okay, car accelerates uniformly. Okay, bachcho. So this A to B portion shows that car accelerates uniformly. Uniformly accelerates means constant acceleration. Then B to C region shows that car is at rest. Okay. And then C to D region shows that decelerate, decelerates uniformly. Okay. Now, so describe the motion of the car. So you have to write down 0 seconds to 10 seconds. Accelerates uniformly. Okay, 0 to 10 seconds accelerates uniformly, and then 10 seconds to 20 seconds. Okay, then 10 seconds to 20 seconds, car is at rest. Car is at rest. Then 20 seconds to 24 seconds, decelerates uniformly. So बच्चों, decelerate means constant negative acceleration. Okay, decelerate means constant negative acceleration. So constant negative acceleration is called deceleration, बच्चों. So now in the next part 2, using figure 7.1, calculate the distance traveled by the car during the 24 seconds of its motion. So students, the speed time graph is given to you, and area under the speed time graph. This area shows distance traveled by car. Okay, so you have to calculate the area under the graph, and this shape ABCDA is trapezium. So the formula for the area of trapezium is half into sum of parallel sides into height. So half parallel sides. The first parallel side is A to D, which is 24, and the second is B to C, which is 10. Okay, so 24 plus 10 times height. The height of the trapezium is 16. Okay, so multiply by 16. So 2 times 8, 16. So it will be 2, it will be 34. 24 plus 10, 34 times 8. The answer is 272 meters. So 272 meter is the total distance traveled by a car. Now calculate the average speed of the car. So students, for average speed, the formula is total distance divided by time. For average speed, the formula is total distance divided by time. Okay. So students, the formula is total distance divided by time. So when you are going to calculate average speed, the total distance traveled by a car is 272 and the total time is 24 seconds. So the average speed is 272 divided by 24. The answer will be 11.33. So the answer is 11.33 meter per second. You should write down 11.3 meter per second. Now, a second. So students, in part 4, a second car travels at a steady speed. It travels the same distance as the first car in the 24 seconds of the journey. So better the distance traveled by the second car is same, which is 272 meter. Okay. And the time is 24 seconds. So speed of the second car is actually 11.33 meter per second. Okay. So examiner asks you to draw a graph, speed time graph for the second car. So students, one box is equal to 0.8. So this is it. So this is 8.8 and 8.8 plus 0.8. This is 9.6. 9.6 plus 0.8. 10.4 and 10.4 plus 0.8. This is 11.2. Okay. So this is 11 point approximately 3. So how can you plot the graph? You have to draw, a flat graph. Okay. So this is how you have to draw the graph for 24 seconds. So this is the graph for a second car, students. Second car. Okay. Because second car is moving with a constant speed, with a steady speed. So now in the next part, the thinking distance is the distance traveled by a car between the time. The thinking distance is a distance traveled by a car between the time that a hazard is seen and the time that the brakes are applied. Okay, so the distance traveled by a car before the application of brake is called thinking distance, and the braking distance is the distance traveled while the car slows down to rest. So when the car applies brake, so the distance traveled after the application of the brakes is called braking distance. Now, table 7.1 shows thinking and braking distance for an alert driver when the car travels at different speeds. Okay. Now, complete the table. So, beta, you have to complete the table. And if you find out that there is a difference of 9 meter, okay, in the previous and the next value. So 9 plus 9, 18, plus 9, 27. So when you add up 80, when you add up 9, when you add up 9, value 9, okay, in 18. So you will get the value for 60 kilometer per hour, 27. Okay, because there is a difference of 9 meter. Now, the time it takes for the driver to react to the hazard is constant at different speed. Explain how the table shows this. The examiner mentions the time it takes for the driver to react to the hazard is constant at different speed. Okay. So when the driver is moving with different speeds, the time it takes for the driver to react to the hazard is constant. So how the table shows this? So, bete, how the table shows this? Because as the speed increases by 20 kilometer per hour, the thinking distance increases by 9 meter. Okay. So both the distance and the speed increases by increases at increases by a constant value. Okay. So for every 20 kilometer per hour increase in speed, there is a difference of 9 meters in the thinking distance. So you have to write down for every 20 kilometers per hour increase in speed, thinking distance also increases by 9 meter. Thinking distance also increases by 9 meter. Okay, so you have to use the table 7.1 to explain the answer. Now, instead, what happened to the thinking distance? So, students, in part 3, state what happens to the thinking distance and the braking distance when the driver is tired. So, bacho, when the driver is tired, so this means that thinking distance will increase because the car will travel more distance in less time. So the thinking distance will decrease. But if we talk about braking distance, so there will be no change on the braking distance. So this is all about question number 3. This is all about question number 3. So braking distance increases. Now, in the next question, figure 1.1 shows a steel spring. Describe an experimental procedure for obtaining the results needed to plot load extension, the extension load graph for this spring. Okay, so how can you record the value, or how can you perform the experiment for obtaining the results? Bete, you need to apply, you need to hang the spring, okay, from one end and attach different loads at the other end of a spring. So when you increase the load, so the length of the spring changes. Okay, so we have to write down, or we have to note down the extension produced for each load. And after that, we have to plot a table between weight and the extension, and then we have to plot the graph. So how can you write down? You have to write down one end of spring is hanged and different loads and load is placed at other end of spring. Other end of spring. Okay, bachcho. So load is placed at other end of the spring and other end of the spring. So uske baad, what we have to do? We have to record the extension produce in spring for each load. Okay, bachcho? Then plot then make a table for extension and load, which help us to plot extension load graph. So bete, after recording the value, you have to make a table. So when you make a table, so the table will help you to plot extension load graph. Okay, so what is the shape of the extension load graph? The extension load graph will be like this. So bete, extension load graph. Okay, so load is placed on x-axis and extension is placed on y-axis. Now, so what is the shape of the graph? First, the graph will be a straight line, then it will be curved to the upward. So this straight line is point P, which is limit of proportionality. So once the spring crosses limit of proportionality, it will deform permanently. Okay. This is the curve. It will deform permanently. Now, in an experiment to obtain results for an extension load graph, a spring is stretched beyond its limit of proportionality. Spring crosses the limit of proportionality. So students, first, the graph is a straight line. Then you have to mark point P, which is limit of proportionality. And then spring crosses limit of proportionality. So it will be a curve moving upward. Okay. So this is how you have to sketch graph, extension load graph. Now, on graph in figure 1.2, mark and label with a P, the limit of proportionality. This is the limit of proportionality. But the limit of proportionality for this spring occurs at a load of 8.5. Okay, so this is the load at which limit of proportionality occurs. The extension of the spring is equal to 0.014 meter when the load is equal to 3.5 Newton. Calculate the extension for a load of 5.5 Newton. So, bete, the limit of proportionality is 8.5, and the examiner asks you to calculate the extension for a load of a 5.5. So 5.5 is below 8.5, means this load lies within limit of proportionality. And within limit of proportionality, the gradient of graph, which is spring constant, the gradient of graph, which is spring constant, the gradient of graph is constant. Okay. And the gradient of the graph shows spring constant. What is a spring constant, bacho? Spring constant actually tell us how hard or soft a spring is. If the value of spring constant is higher, it means the spring is hard. It is difficult to compress or stretch that spring with a higher value of K. If the value of K is low, it means the spring is easier to stretch or compress. It's a soft spring when the value of K is low. Now, beta, you have to apply ratio method where you have to apply the ratio between load and extension. When the load is 3.5, the extension is 0.014 meter. When the load is 5.5, then you have to calculate the extension, cross multiply it. So 3.5 is equal to 0.014 times 5.5, 3.5 E. Now the value for E is 0.014 times 5.5 over 3.5. So the answer is 0.014 times 5.5 divided by 3.5. The answer is 0.022 meter. So this is the extension, 0.022 meter. This is the extension produced at 5.5 Newton load. Now, in the next part, a child's toy consists of a flexible track and a model car. Figure 2.1 shows a diagram of the toy. Okay, the toy is released from a height of 0.5 meter. Now, students, the child first hold the car stationary at point A, which is 0.45 meter above the horizontal section of the track BC and FG as shown in the diagram, which I marked for you, highlight for you. The mass of the car is 0.12 kg. Now, the child then releases the car which travel towards B. Both air resistance and friction between the car and the track are negligible. Now, students, calculate the change in gravitational potential energy of the car as it travels from A. So, beta, when the car travels from A, it means the height decreases. So, the formula for GP is mgh. The mass of the car is 0.12 kg. Okay. The mass of the car is 0.12. The value for G is 10 and the value for height is 0.45. So what is the answer? The final answer will be 0.12 times 10 times 0.45. The final answer is 0.54 joules. 0.54 joules. Now, calculate the speed of the car when it reaches B. Guys, the air resistance and the friction between the car and the track are negligible. It means the loss in gravitational potential energy is equal to gain in kinetic energy. So you have to use the equation kinetic energy is equal to half mv square. And we have to make v square subject. So 2 times kinetic energy over m. Now what we have to do? Under root, and we have to place the value 2 times 0.54 divided by the mass is 0.12. So the final answer is 2 times 0.54 over 0.12. The final answer is 3 meter per second. 3.0 meter per second. Now, after releasing it, the child expects the car, the child expects the car to follow the track along the route A, B, C, D, F, E, F, G. So, बच्चों, what a child the child considered that the car will follow the track along the route A, B, C, D, E, F, G. In fact, the model car does not reach F. Okay. The model car does not reach point F. The model car does not reach this point F. So you guys know that why the model car does not reach point F, because it doesn't have enough energy to reach that point. Now, explain in terms of energy why the car does not go past B, okay, which is also 0.45 meter above the horizontal track. Examiner ask you to tell why the car does not pass past point D. So beta, the car does not pass point D. So the main reason is that the car doesn't have enough energy. Okay, so if the car have enough energy, so it will pass point D. But the car does not go past D. Why? Because the car doesn't have enough energy. So you should write down car doesn't have enough energy. Okay, now immediately after being released at A, the car travels to B, to C, and then to D. Describe the motion of the car after it reaches D. So beta, when the car reaches D, it will again go back to C, it stops, and then again return back to C, B, A. Okay. So you have to write down car stops and return to C, then B, then A. Now, question number 6. Figure 7.1 shows a child sitting on a sledge on a snow-covered hill of constant slope. Okay, bacho? So at t is equal to 0, the child and the sledge begin to move down the hill in a straight line. When the car sees a wall ahead, when the child sees a wall ahead, he applies the brake. Okay. When the child sees a wall ahead, he applies the brake. So the child and sledge continue to travel in a straight line until they come to a stop before hitting the wall. Now, figure 7.2 is the speed time graph for the journey. So students, the brake is applied at 26 seconds. So this is the time, this is the point where brakes are applied. Okay, this is the point where brakes are applied. Now, figure 7.2 shows how the speed of a child and sledge varies over the whole of the journey. Explain why between 0 and 26 seconds the speed varies in the way shown by the graph. So, bacho, at start the graph is a straight line. Okay, then it will be a curve, and then it will become flat. So at first the speed increases, or the acceleration, the car accelerates, or the car moves with maximum acceleration, and then the speed increases but the acceleration of the car decreases, and at last the speed becomes constant but the acceleration is 0. So this is the point, this is the portion of the graph where acceleration is 0, bacho. Okay, so you have to explain why the graph, why the speed varies in the way shown by the graph. So you have to write down at start acceleration, and at start acceleration is maximum. Okay, bacho, at start acceleration is maximum, and and speed increases, then acceleration decreases. Okay. At last, speed of speed becomes constant. At last, speed becomes constant and acceleration is zero. So, bachcho, you should also write down the car speed ups with uniform rate and then moves with decreasing rate, and at last speed becomes constant. Now, at 26 seconds, the front of the sledge is 35 meter from the wall. The front of the sledge is 35 meter from the wall. Determine the distance between the front of the sledge and the wall when the sledge stops. So, beti, the front of the sledge is 35 meter from the wall. So, examiner asks you to determine the distance between the front of the sledge and the wall. Okay. So, how can we calculate the distance between the front of the sledge and the wall of when the sledge stops? So, we have to calculate this area under the graph. Okay, bacho? We have to calculate this area under the graph. This is 26. We have to calculate this area under the graph. This is a right angle triangle. So the formula is half into base into height. Half, the base is this is 30, 26, and then 28, then 30. This is 30. So the answer, it will be 4. Okay, the base is 4 and the height is bacho. The height is 12, 13, 14. No, 10 boxes is equal to 10 boxes shows there is a difference between 16 and 12, 4. 10 boxes shows 4 meter per second. So one box shows 0.4, okay, meter per second. So, bacho, two boxes is equal to 0.8. So this is 12.8 and 12.8 plus 0.8, it is 13.6, and then 0.8, it will be 14.4. This is 14.4, and then 0.8, 15.2. Okay, 15.2 is the height. 15.2. So 2, and 15.2 times 2 is 30.4. So the distance is 30.4 meter. Okay. The examiner asks you to determine the distance between the front of the sledge and the wall. So, bete, the distance between the front of the sledge and the wall is calculated by area under the graph. Now, at 26 seconds, the child and sledge begin to decelerate. Determine the size of deceleration. So, bete, for deceleration, you have to calculate the gradient of this graph. This point is 30, 0, and this point is 26, 15.2. You have to calculate gradient. So 0 minus 15.2, the formula is y2 minus y1 over x2 minus x1. Y2 is 0, y1 is 15.2, and it will be 30 minus 26. So 15.2 divided by 4. The answer is minus 15.2 divided by 4. The answer is 3.8, minus 3.8 meter per second square. And deceleration is written here. So no need to play, no need to write down the negative sign. You just have to write down the value. Now, the mass of child is 46 kg and the mass of the sledge is 9. Calculate the resultant force on the child and sledge as they decelerate. So the formula is MA. The mass is 46 plus 9 and the deceleration is 3.8. Okay, bacho? So the answer is 46 plus 9 is 55 times 3.8. The resultant force is 209 newtons. Now, state the energy transfer that is taking place as the child and sledge decelerate. So, bete, when the child and sledge decelerates, so what happens? The kinetic energy changes into heat energy. Okay. So the because the brakes are applied, so the sledge and the child both slows down, na? So their kinetic energy decreases, and at the same time, there is a heat loss due to friction. So you have to write down they both are decelerating. So and their height constantly decreases. So you have to write down gravitational potential energy changes to kinetic energy, which changes to which decreases and changes to thermal energy. Okay, bacho? So first, the height decreases. So gravitational potential energy changes to kinetic energy, and the speed again decreases, and speed decreases. So kinetic energy decreases and changes to thermal energy because of the rubbing between the surface of sledge and the slope. At t is equal to 26, when the brakes is first applied, the child jerks forward on the sledge. Okay, explain why. Because of inertia. Okay, so beta, you apply force, na? You apply braking force in order to change the state of motion into state of rest. But the inertia resists this change. So because of inertia, the child moves forward. Okay, jerks forward on the sledge. Why? Because inertia continues its state of motion and resist to change it into state of rest. Okay. So, bete, so you apply the brake in order to slow down the sledge, but the inertia resists this change. Okay. Inertia resists the change of state of motion into rest. But the inertia of a child tries to continue state of motion. Okay. Try to continue states of motion. Try to continue state of motion. Instead, the braking force is applied. So the inertia try to continue the state of motion. That's why the child sitting on a sledge jerks forward on the sledge. Now, question number 7. A train travels along a straight horizontal track. At time t is equal to 0, the train passes through station P at constant speed without stopping. The driver applies the brake at 70 seconds. Okay. So this is the time where driver applies brake. Now, before reaching station Q, okay, the train reaches station Q. But you have to study the diagrams or the graphs also, because the graphs and the diagrams given in each and every question is of greater importance. The train decelerates when the brakes are applied. The train decelerates. Okay, this graph shows the deceleration. This is the speed time graph. Okay, now use figure 1.1, determine the distance between station P and Q. So guys, for distance between station P and Q, you have to calculate area under the graph. Okay. So this is a trapezium. So formula is half into parallel side. One parallel side is 0 to, this is 120 and 140. Na? So 130. This is 130. So it will be 122, 124, 126. So 126 plus the second length is, the second length is 41, 2, 3, 4, 5. This is 50, bacho. 52, 54, 56. So the second length is 56 times height. The height is, how can you calculate the height? 60. This is 70, 72, 74, 76, and 78. In the mid of 76 and 78. So this is 77. 77. So what is the value? 0.5 times 126 plus 56 times 77. The answer is 7007. Okay. It will be round off to 7,000 meters. So this is the distance between two stations. The mass of the train is 3.8 exponential 5 kg. Okay, but the mass of the train is 3.8 exponential 5 kg. Determine the deceleration of the train in the 70 seconds before it stops at station Q. Deceleration. So, bete, for deceleration, you have to use the formula for gradient, x2 minus x1. Okay. So, this point is 126, 0, and this point is 56, 77. So 0 minus 77 divided by 126 minus 56. So the gradient is 77 divided by 126 minus 56. The answer is 1.1 minus 1.1 meter per second square. This is the deceleration, bacho. Deceleration is written here, so no need to mention negative sign. So 1.1. Now, calculate the resultant force on the train as it decelerates. So for resultant force, we have to use formula F is equal to ma. The mass of the train is 3.8 exponential 5. Okay, 3.8 exponential 5. And the acceleration is 1.1. So the value is 1.1 times 3.8 exponential 5. The answer is 4,18,000 newtons. In scientific notation, it will be 4.18 exponential 5 newtons. Okay, 4.18 exponential 5 newtons. Now, The foundations, question number 8, the foundations that support a building are long concrete cylinders that are pointed at one end. Okay. A driver is a machine. This is a pile driver. Okay. A pile driver is a machine that forces pointed concrete cylinders into the ground. Okay. Now, students, a heavy block of mass. You need to extract the information from the question by reading it carefully. This is the mass of the heavy block. Now, it's lifted into the air and then dropped onto the top of the concrete. So when the heavy block is dropped, this block apply force on the concrete, causing pressure, which ultimately penetrates the concrete cylinder inside the ground. The force, this forces cylinder into the ground. Okay, when the heavy block hits the surface of the concrete cylinder. So the heavy block apply force on the concrete cylinder, and this force causing pressure which penetrates the concrete cylinder into the ground. Now, figure 2.2 shows the heavy block. So bete, this is a heavy block, and this is the area. This is the height of the block. Now, the block is 2 meter tall and the cross-sectional area is 1.8 meter square. Now you need to calculate the density of the material used to make the block. Now, density of the material. So how can you calculate the density? Bete, for density, the formula is mass divided by volume. The value for mass is 2.9 exponential 4 kg. And how can you calculate the volume? You need to multiply the height and the area. Okay. So 2 times 1.8. The volume is area times height. Now, the answer is 2.9 exponential 4 divided by 2 times 1.8. The answer is 8055.6. 8055.6 kg per cubic meter. So you should write down 8056 kilograms per cubic meter. Now, students, the pile driver lifts the block from the top of a concrete cylinder through a height of 0.8 meter. Okay, the block is lifted to a height of 0.8 meter. Then it is released and the block hits the surface of the concrete cylinder. Apply force on the surface area of the concrete cylinder, which causes pressure, and the concrete cylinder penetrates into the ground. Calculate the gravitational potential energy gained by the block. So you have to use mgh. The mass of the block is the mass of the block is 2.9 exponential 4. 2.9 exponential 4. This is the mass of the block. The value of G is 10. The value of G is 10. And the height is 0.80. Now, students, you need to calculate 2.9 exponential 4 into 10 into 0.80. The answer is 2,32,000. 2,32,000 joules. 2,32,000 joules. Now, the block is then dropped from rest onto the top of the concrete cylinder. Calculate the speed of the block just before it hits the concrete cylinder. So, bete, when the block hits the concrete cylinder, when the block moves downward, the GPE changes into kinetic energy. So, kinetic energy is half mv square. So, v square is equal to 2 times kinetic energy over m. So, what is the value of v? Square root 2. Kinetic energy is the gravitational potential energy, 2,32,000. And the mass is 2.9 exponential 4. So the answer is under root 2 times 2,32,000 divided by 2.9 exponential 4. The answer is 4. The answer is 4 meter per second. 4 meter per second. So students, here we completed the first part of this video. I'm going to discuss the remaining questions in the second part of the video. So thank you for watching the video.